We have a two-lane major rural highway, and for that we will compute equivalent single action load for a design period of 20 years. And we'll go over the data what we have. But before that, we'll write down the equation for ESAL. The equation for ESAL is the ADT data you have currently, and it will be multiplied by the percentage of track. In this case, this is 25%, and it will be multiplied by track factor. Later, it will be multiplied by G, which is growth factor, then D, which is called directional distribution, and then it will be multiplied by GDL, lane distribution factor. Later, it will be multiplied by Y. What does it mean? It means the design period, in this case 20 years, and it will be multiplied by 365. So actually ESL means if we convert all the traffic in terms of 18 cube axle load, it will the number of times this axle load will go over a particular section is ESAL. It's just a number that a particular axle repeats itself over the design period. However, let's do the math. So here A D T, just ADT, I would call it ADT, not is 4,000, and I have a truck. I need to find out the truck factor. How do we find that? Just look here. We have a rural highway. Well, and it's two lane and it's major. So it's a rural system and it's an urban system. And here is the vehicle type. We will select all types, and you may get confused that here is major, but it's for collectors. We are not asked to find out the collectors, so it's not interested. But we'll select other principal. For that, we'll get a value of 0.38. This is our truck factor. Truck factor is 0.38, and truck percentage is 25%, which is 0.25. We need some other values like G. I'll calculate it a little bit later on. We need directional distribution. In this case, it is 50%, so zero point 0.5. We need a lane distribution factor, and for two lane, it is actually 100%. This means one. I'll show it. It's actually two lane. It was two lane. So number of lanes in each direction. So let's say the traffic will go this direction and the traffic will come this direction. So in each direction, you just have one lane. So for that, you it's just one, and percentage of 18 tip ESL in design lane is 100%. So this value is one. You need to know the value of y. So you are asked to find out the ESL for 20 years. So y is 20. The only thing that we didn't calculate is g. For g, we have three equation. G for g, we have three equation. We'll calculate it. The first equation is for average method. That is, you just take half, you have 1 here, and you have 1 plus r to the power y. So here we have half, and we have 1 plus, we have a annual growth rate is 4%, so it would be 1 plus 0.04 to the power, we have a design period of 20 years. So from that I'll get a g value of, let me calculate, 1.6. Later I have it was for average method. Later I'll find for PCA method. For that, g is equal to 1 plus r to the power point 5 y. So it would be 1.04 to the power point 5 multiplied by 20. You will get a value of 1.48 if I'm not wrong. Yeah. You have another equation that is for AI and Ashton. And the equation is a bit long, 1 plus r to the power y minus 1 over y times r. So in this case it will be 1 0 to the power y is 20 minus 1, and y is 20, it will be 0.04. You will get a value of 1.48. So amongst these 3g, we'll consider the largest one, which is 1.6. So the g is 1.6. So let's write down the formula. A d d is 4,000, and you have a truck percentage is 25%. You have a truck factor of 0.38. You have a g value of 1.6. You have a directional distribution of zero point 0.5. You have a lane factor of 1, and you'll multiply it with design life, which is 20, and you'll multiply it with 365. So from there you'll get a value of 2052,2052,760. Typically we convert it in terms of millions, so 3 3, so it is around 2.05 times 05 million. So, an equivalent actual load of 18 kip will pass over a pavement around 2 million times. So, this is the math. We'll do more maths on pavement design.